Ever use one of those sleek new AI features? Maybe editing a photo, blurring your video background, and suddenly your device gets hot. The battery just plummets or things just start to lag. Yes, it's like there's this hidden AI tax we pay in performance and battery life. But there's a specific piece of silicon showing up everywhere now that's designed to make that tax disappear. Welcome back. Now, inside our phones, laptops, tablets, even desktops, we know the main workhorses, right? The CPU, the general brain running the show, the GPU, the graphic beast pushing pixels for games and visuals. But running AI efficiently, that demands something different. And that's why this third kind of chip is becoming so crucial. The NPU, the Neural Processing Unit. Most people don't even know it's there, but it's quietly becoming the key to making AI feel effortless. Okay, but why? Why can't the incredibly fast CPU in your laptop or the powerful GPU just handle all this AI stuff? They're powerful chips. Well, they can try, but it's really not what they were built for. Think about what modern AI involves. Tons and tons of relatively simple calculations, but they need to happen all at once, in parallel. It's a very specific kind of workload. Your CPU? Amazing generalist, great at complex step-by-step instructions, but trying to juggle thousands of those parallel AI calculations, it gets bogged down, feels slow for that job. Your GPU? Much better at parallel work. That's why the giant AI models train on huge GPU farms. But using your power-hungry gaming GPU constantly for the smaller, persistent AI tasks running on your phone or laptop, like always listening for voice command or processing video effects in real time, that's like using a monster truck for a quick grocery run. Total overkill. It absolutely kills battery life and generates a surprising amount of heat. It just doesn't scale efficiently for the kind of seamless, always-on AI features we're starting to expect. We needed a smarter approach, sometimes purpose-built for the unique math of AI, and that chip is the NPU. So the NPU, Neural Processing Unit. What's its secret weapon? In one word, efficiency. This chip isn't trying to be the fastest at everything or render the most complex games. Its entire design, down to the silicon level, is obsessed with performing the specific type of mathematical operations common in AI. Think matrix math, vector stuff, using the absolute least amount of energy possible. Imagine needing to translate a whole book. The CPU is like trying to do it with a dictionary, looking up words one by one, slow and tedious. The GPU is like having 1,000 people with dictionaries, faster but chaotic and resource intensive. The NPU is like having a fluent, expert translator who just knows the language, incredibly fast and efficient for that specific task. It's a specialist. And why does this specialized efficiency matter so much in the real world? It unlocks a couple of huge advantages you actually feel when using your tech. The most obvious one, your battery doesn't instantly die, and your device doesn't feel like lava. By handling those constant AI calculations using way less power, the NPU allows developers to integrate smart features without you constantly hunting for a charger or worrying about your laptop burning your lap. That background blur, the real-time captions, the NPU lets them run without that painful AI tax on your battery. That's huge for portability. The second massive benefit, and maybe even more important long-term, is enabling powerful on-device AI. Because the NPU can handle complex AI math efficiency right there on the chip, more processing can happen locally on your phone, tablet, or laptops instead of always needing to send your data to some giant server farm in the cloud. Keeping things local is a game changer. You get that instant speed and responsiveness. When the AI runs locally, there's no lag waiting for data to travel back and forth. Real-time features just feel instantaneous, like they're part of the device itself. You get significantly better privacy. If the AI is processing your face, your voice, your documents right there on your silicon, that sensitive data doesn't have to leave your device. In an era of constant data breaches and privacy concerns, that's a fundamental shift towards giving you more control. And sometimes you even get offline capability. AI features that can run entirely on the NPU can work even without an internet connection. Think on-the-fly translation or certain photo edit when you are traveling. Super useful. This move towards powerful, efficient, on-device AI processing is happening everywhere. Intel's Core Ultra chips for laptop feature integrated NPUs. AMD has their Ryzen AI platform. Qualcomm's Snapdragon chips powering countless phones, laptops, tablets, and have their Hexagon processor. And Apple, they've arguably been leading the charge here for years with their neural engine, a core part of their A series chips in iPhones and iPads, and the M series chips in Macs. Different names, maybe slightly different architectures, but the same core goal. Dedicated silicon designed to make AI run efficiently, right on your device. It's the new standard. Does knowing more AI runs locally make you more likely to actually use those features? Okay, better battery, instant speed, more privacy. The benefits are clear, but let's get specific. What are the actual features, the cool experiences that this NPU or neural engine tech is unlocking right now? Alright, where does this NPU neural engine horsepower actually show up in your day-to-day? You're likely benefiting from it constantly without even thinking about it. For instance, think about video calls. You know that smooth background blur effect that hides your messy room? Or the auto framing that cleverly keeps you centered if you shift around? Maybe even that slightly uncanny eye contact correction that tries to make it look like you're staring right at the camera. Doing those effects constantly, analyzing every frame in real time, used to absolutely punish your CPU and make your laptop fan scream. Offloading that continuous workload to the efficient NPU or neural engine means smooth effects, less lag, and your battery doesn't cry for help after a 30-minute meeting. It makes these features actually practical. Or how about smarter voice interaction? Things like having your device instantly transcribe a meeting in real time accurately, or intelligently filtering out the background noise when you're trying to talk on your phone in a busy place. Even just the ability for your device to constantly listen for "Hey Siri" or "Okay Google" using minimal power. That low power, always on audio processing is a perfect job for the NPU neural engine. It makes voice features faster, more reliable, and less of a battery drain. Photography is another huge area. That computational magic that happens the instant you press the shutter, recognizing faces to nail portrait mode, analyzing the scene to optimize colors and exposure, maybe using AI to sharpen detail or reduce noise in low light. The NPU neural engine accelerates these complex image processing tasks, giving you better looking photos and videos instantly without waiting for processing. And this is core to whole AI PC concept that companies like Microsoft, Intel, and AMD are pushing for laptops. They're building features directly into the operating system, like live captions for any audio sources, advanced webcam effects in Windows Studio Effects, maybe even controversial features like recall that rely on having a capable NPU on board to run efficiently and locally for a responsive experience. The goal is to make AI feel like a neutral extension of your computer. We're even seeing hints of it in gaming. While the GPU remains king for rendering, NPUs could power smarter, more realistic AI opponents in games without impacting frame rates, or maybe enable more efficient AI-based resolution upscaling. Still early, but the potential is there. And it's not just the headline features. Snappier predictive text, faster secure facial unlocks like Face ID, quicker on-device summaries, all these little background AI tasks that make our devices feel smarter and more responsive benefit from having dedicated, efficient hardware. The overall theme, the NPU neural engine is the key ingredient making AI feel integrated, instant, and invisible. It handles the constant low-level AI work efficiently, taking the burden off the main processors. This allows developers to build in more intelligence without the user constantly noticing performance hits or battery drain. It's about making AI a seamless part of the experience, not a clunky add-on. Alright, let's land this. The NPU, Apple's neural engine, whatever the name, it's not replacing your CPU or GPU. Think of it as adding a crucial hyper-efficient specialist to the silicon team. Its whole job is running AI tasks using way less power. The payoff for you? Faster, more private AI features woven seamlessly into your phone, tablet, and laptop experience without murdering your battery. And yes, this dedicated AI hardware, it's absolutely the new standard. These dedicated AI chips are only getting better, unlocking more possibilities for on-device AI. What kind of local AI features running right on your gear are you most hyped about? Faster photo editing, truly smart assistants that don't need the cloud, better privacy? Let me know what you think down in the comments. And hey, if you enjoy breaking down the tech that makes our gadget tick, definitely make sure you're subscribed. Okay, that's the inside scoop on NPUs and neural engines. Hopefully makes a bit more sense why this little chip is such a big deal. Thanks as always for watching. Until the next one, catch.